Hello, the topic of this presentation is superconductors. So what is a superconductor? A superconductor is a material that can conduct electricity without energy loss and offers no resistance. This generally can happen when the material is cooled to a critical temperature. And that critical temperature is often at just a few degrees above absolute zero, which makes it impractical to achieve. So how do superconductors work? First of all, superconductors are made with materials that are electrically neutral, which means that the atoms of the materials have negatively charged electrons that surround the nuclei with the same number of protons. Let's say we have a wire with one end attached to something that is positive and the other end attached to something that is negatively charged. The electrons in the wire will want to move through the material to reach equilibrium. At normal temperatures, the electrons would mostly move freely through the wire, but some would collide with the nuclei of the material. And these collisions would block the flow of electrons and thus cause resistance and the material will heat up. The nuclei of all atoms are always vibrating, and in superconducting materials, the electrons would flow in a way that is in sync with the vibrations of the nuclei. Their coordination and movement results no collision, and therefore no resistance and no heat. And as a material gets colder, the movement of electrons and nuclei becomes more organized, and that gives the reason to why typical superconductors only work at extremely low temperatures. So how does the magnet flow on top of a superconductor? This is due to the Meissner effect. It occurs when a magnetic field is applied to the superconductor, and the superconductor creates a magnetic field that exactly cancels the magnetic field outside and repels it. And so the magnet repels and floats. In the past, superconductors were used in MRI machines and magnev trains. And in the future, it seems likely that superconductors can be used for many other purposes, such as powering quantum computers. So the recent discovery regarding superconductors is that a group of scientists were able to attain a possible world's first high-temperature superconductor by placing together two cuprate superconductors and twisting them in a certain way. This is important and has the potential to become revolutionary because, as mentioned before, superconductors were only able to be produced at extremely low temperatures. But if they are able to be made at relatively normal temperatures, then the production would be much more practical to achieve.